So question 8 tells you that we have this pan, which is in the shape of a cylinder, that we are going to be creating a pizza in, or using to cook a pizza. So the first part asks you to calculate the volume of the pan. So to do this, we're going to be using our volume formula for a cylinder. So that's pi times r squared times the height of the cylinder, and that's going to give us the volume. So if we plug that in with the numbers we have, then the volume is equal to pi times r squared, which is 17.5, times the height, which is 0.5. So we know that the diameter is the 35, and we're interested in the radius. So we know that the radius is the 17.5. And if you plug that into your calculator, you then get 481, and the units we're dealing with are centimetres cubed. We know that it's volume, which is cubed, and we can see there that the units are centimetres given in the question. So it's for 3 marks. 1 mark is for the correct use of the formula and inputting it correctly. And then the second 2 marks are for the answer and for the units. So 2 marks for the answer and the unit. The second part of the question says that the chef has enough pizza dough and it's in the shape of a sphere or a ball. Okay, so we're working with a ball in this part of the question. And we're needing to find the radius of the ball or the sphere. And we're told that the volume is the 481. We know that it fits exactly into the pan. And we're told that that volume was measured to the nearest 1 decimal place. So if it's 481 centimetres cubed, then that means that the upper and the lower bounds, if it's been rounded to 1 decimal place, are 480.5 as my lower bound and 481.5 as my upper bound. So they're the upper and lower bounds for my volume. So I now need to find the radius using those measurements. So we know that the volume of a sphere is 4/3 of pi r cubed. So that's given to you in the formula book. So we're going to use the volume first of all as 480.5. So 480.5 is equal to 4/3 pi r cubed. And that's going to give me the lower bound for my radius. And then I'm going to do the same again for my upper bound. And this time it's 481.5 as my volume. And that's equal to 4/3 of pi r cubed. And you can type that into your calculator to solve. Okay, and then that gives you a radius of 4.86 and a radius of 4.86. So to 3 significant figures, they're actually the same answer. Okay, and they're in centimetres, both of those. So in terms of the marks, there is 1 mark for working out each of the upper and lower bounds of the volume. There is a mark for correctly inputting into the formula. Okay. And then there's a mark for each of the upper and lower bound answers, which happen to be the same.